AI now creates hours of video, changing the plot live. This is a massive leap for interactive storytelling. Let's get into it. Let's start with a featured paper, Visko Orbis 1.0, a live model for real-time interactive long video generation. By Team Visko. This paper presents a significant leap in real-time, interactive long video generation, addressing a critical limitation of previous models and enabling new applications. Here's a full breakdown.
Our process begins with creating a distilled streaming generator, which is the core engine for real-time creation. After several training and adaptation steps, we arrive at the final post-training stage, which uses distillation to produce the efficient final model. Feeding into this, we use a novel memory mechanism to maintain consistency across long videos. This is developed during the streaming adaptation phase, which trains the model to remember subjects and styles across different video chunks. Finally, to achieve high visual fidelity, the paper incorporates a streaming video upscaler. This component, which operates after the generation pipeline shown here, enhances the content to deliver real-time 4K video. Visko Orbis 1.0 achieves the highest overall arena score, yellow, among the listed methods. With an yellow score of 1,838, it substantially outperforms the next best method, Happy Oyster, and all other baselines.
Up next, our second paper out of 3, Hearsay, Vision Language Medical Diagnoses Without an Image by Siddharth Vora from Carnegie Mellon University. This work reveals a significant and concerning failure mode in frontier vision language models, demonstrating systematic confabulation in medical diagnoses based solely on demographic information, which has serious ethical and practical implications. Let's break down its key contributions.
This heat map measures how much a model's diagnosis changes when we only alter the patient's demographic details, which are listed across the bottom. The intense red coloring in the GPT-4v rows shows its diagnoses are highly sensitive to these demographics, especially compared to the pale Gemini Pro rows below. Drilling down on this, we found a peculiar failure where models would state they couldn't see an image, yet still output a specific diagnosis. This is most pronounced with Claude Opus in the dermatology domain, where for the 65-year-old white female demographic, the diagnosis shifts dramatically, hitting a JSD of 0.83. Finally, we also found that these confabulations are sensitive to subtle changes in the prompt's wording, like using skin mole versus skin lesion. While this specific chart doesn't break down results by individual probe words, it does show how different medical domains, like X-ray versus dermatology, trigger vastly different levels of bias within the same model. Claude Opus 4.7 and GPT 5.4 demonstrate a strong demographic signal, with GPT 5.4 achieving the highest ratio of demographic signal to paraphrase noise at 13.9x. In contrast, Gemini 3.1 Pro exhibits a much weaker demographic signal, falling below the 0.10 pre-registered threshold.
Up next, our third paper out of 3, Mental World Modeling by Hao Fei and Iran Zhao from University of Oxford. This paper proposes a fundamental extension to the concept of world models by introducing mental world modeling, which incorporates hidden mental states, addressing a critical gap in AI's ability to understand and predict human behavior. Let's break down its key contributions.
Let's start with the overall mental world model, our omniscient simulator on the left. It uniquely tracks both a current physical state, like where the gift is, and a current mental state, showing what Alice and Bob are thinking. This framework is instantiated as a process broken into distinct, manageable phases. We see this as the flow from Step 1 through Step 2 and into Step 3, which allows for a clear, inspectable simulation. Feeding into the process, Step 1 is the observation generation. Here, the model simulates what the target, Alice, would observe, creating both a physical observation of the scene and an inferred mental observation about Bob's state of mind. Next, the system proposes an action and simulates its consequences. This happens in Step 3, the world state transition, which models how Alice's actions will jointly create an updated physical state and an updated mental state. Finally, the model evaluates the outcome of this simulated branch to predict the best decision. The result of a positive evaluation is reflected in the updated mental state, where Alice concludes that her goal is met because the surprise is still safe.
Those were the top papers. Now, let's zoom out. ArXiv received 572 new computer science papers across 57 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into four big themes: human-centric generative vision, trustworthy AI and LLM evaluation, AI for diverse prediction tasks, algorithmic advances, and system design. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.